Okay, sorry for that funny clip. I made a mistake, so I clipped it. So we just worked out that the rate of migration for our two individuals that we're following, our two lineages, is 2m. Okay, so now we'd like to get the time to coalescence. So if we pick two random individuals in the population, how much time do we have to, what's the expected time to coalescence? Okay, so this is going to get a little gnarly here. So we're just going to use C for the rate of coalescence, which is equal to, so what's the probability of coalescence for two individuals in the same population? So if two individuals are in the same subpopulation, well, if there's n individuals in the whole population and they're equal size populations, then that would be that would be 2. 1 over, that would be n over 2 individuals in the population, and so the rate of coalescence would be 1 over n over 2, or 2 over n. Okay? So we've got the rate of migration is this, and the rate of coalescence is this. So then we can work out the expected time overall that we're going to have to wait for two individuals to coalesce. So let's start with, so when we pick two individuals randomly, they're either in the same population or they're in different ones. It's slightly easier to go through it if we start with different ones, so let's do that first. So we're going to do the expected time to coalescence given that they're in different subpopulations. Okay? All right, so if they're in different, so let's think about the events that are going to occur here. So there are two different kinds of events that we're interested in. One is that an individual migrates, either this one migrates over here or this one migrates over here, or the two individuals coalesce. So if migration is rare and if coalescence is rare, if n is pretty big, then the probability that they happen in the same generation is pretty small. So we're going to ignore that and just ask, what's the series of events? So if we start if we start here in the present and go back, so the two individuals are in different subpopulations, so the first thing that's going to happen is a migration event. And then the second thing that happens is either, so one of the individuals migrates, either this one over here or this one over here. So now they're in the same population. So now the second event, as we go back in the past, could either be a coalescence, in which case we're done, or it could be a migration event. If it's a migration event, then we have to wait for another migration event, right? Because if one individual migrates over here, then we have to wait for another migration event to get them back in the same population. And if that's the case, once that migration occurs, then the next event could either be a coalescent event from the two individuals in the same subpopulation, or it could be a migration. If it's a migration, then the next one has to be a migration, and the one after that could be either migration or coalescence. And so we get a tree like this.